Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to be talking about the multiplication rule. Yes, we're still talking about probability. In the last video, we talked about the addition rule, and this one is the multiplication rule. But before we can actually talk about the multiplication rule, we need to understand two very important terms: independent events and dependent events. So two events E and F are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. So if you think about two different events, if the chances of one happening does not affect the chances of another one happening, then those events are independent. And vice versa, two events are dependent if the occurrence of event E in a probability experiment actually affects the probability of event F. So if we have two events, and if the chances of one happening affects the chances of another one happening, then those two events are dependent, all right? So independent means they stand alone. Dependent means they depend on each other. So let's look at an example. Determine whether the following events are independent or dependent. So we have event E is speeding on the interstate, and event F is being pulled over by a police officer. Will the probability of one event happening affect the probability of another? So when you think about it, if you're speeding on the interstate, will that change your probability of being pulled over by a police? Yes, most definitely it will. And so in this case, the probability of one event actually affects the probability of another event. So these events would be considered dependent. And I'm just going to write a D here for dependent. All right. Next example is you gain weight. That's event E, and event F is you eat fast food for dinner every night. Will the probability of one event have an effect on the probability of another event? And in this case, if you think about it, yeah, if you eat fast food for dinner every night, that probability of that will definitely affect the probability of you gaining weight. So in this case, they are also dependent upon each other. So these are dependent events. All right, and then we're going to look at one last example. The first event, and that should be C, not B right here, but event E is the high score on a statistics exam, and event F is the Boston Red Sox win a baseball game. So will the probability of this event happening affect the probability of this event happening? And as you can see, these have totally nothing to do with each other. And in this case, these are independent events. So I'm going to write an I right here for independent events. All right, so part A was dependent events, part B was dependent events, and part C, this should be part C, is independent events. Let me know if you have any questions about these. All right, now we can get to the multiplication rule because there's a different rule that you'll use for independent and dependent events. And in this video, we're only going to talk about the multiplication rule for independent events. So if E and F are independent events, then you will find the probability of E and F by doing the probability of E times the probability of F. All right. So it's important to know here that the multiplication rule is used for and events, and whereas the addition rule we used last time was for or events. So you use addition for or and multiplication for and. So if E and F are independent, then you will just find the probability of E and F by multiplying the probability of E times the probability of F. And you can extend that. So if you have multiple events that are independent and you want to find the probability of and all those events, so E1 and E2 and E3 all the way to En, then you will do the same thing. You will just multiply all of those probabilities. So this is just an extension of this multiplication rule with two events to multiple events. Okay, let's look at an example, and I skipped one. Let me go back. What is the probability of obtaining 4 heads in a row when flipping a fair coin? We want to find this probability and we want to interpret it, okay? So we want to know what is the probability of getting a head and another head and another head and another head. So that means we're going to flip a coin 4 times and we want to know what's the probability of getting a head each time. So we have to ask ourselves, are these independent events? Meaning, if I flip a head one time and I flip the coin again, will what I got on the first time actually interfere with what I get the second time or determine what I get the second time? In this case, no. It doesn't affect what you get each time. So these are independent events. Since you're just flipping a coin, each time you flip the coin will be considered an independent event. So since it's independent events, then if we want to find this probability, that will be the same as saying probability of heads times probability of heads times the probability of another head times the probability of another head. Well, what's the probability of getting a head? Well, you can get a head one time out of two options, a head and tail. So you would do 1/2 times 1/2 times 1/2 times 1/2. And that's the multiplication in between those. So that's the same as doing 1/2 to the 4th power, which is 1/16, which if you divide that out, that comes out to approximately 0.0625. So that will be your probability, 0.0625. And what does that mean? So the interpretation of that is, if we was to do this experiment 100 times, because this is approximately 600s, but if you read it out, we normally interpret things in terms of hundreds. So that's why I'm stopping here at the hundreds place right here. So this is approximately 600s. So if we were to repeat this experiment 100 times, we can expect to get 4 heads in a row 6 of those times, okay? If we was to repeat this experiment, flipping a coin 4 times, if we repeated that 100 times, we can expect to get all heads about 6 of those times, all right? So that's how you would interpret that probability. Let me know if you have any questions about this problem. Put them in the comments or email me, all right? If not, we are going to go to the next example. Oh, before we go to the next example, there's another type of probability dealing with at least probabilities. So if you want to take the probability of something that uses the phrase at least, then you use the complement rule. And let's recall the complement rule. So the probability of E complement is equal to 1 minus the probability of E. So if you use the complement rule, you're just going to do 1 minus the probability of that thing happening. And you'll use that whenever you're taking the probability of at least something happening. And so now let's jump into the next example. The probability that a randomly selected 40-year-old male will live to be 41 years old is 0.99757. That's according to the National Vital Statistics Report, and that's the information where you can find it. We want to know, what is the probability that 5 randomly selected 40-year-old males will live to be 41 years old? So you have to think about it first. What is it that you want? You want the probability that when you select 5 individuals, that they'll live to be 41. So I'm just going to use L to represent live to be 41. So I want the probability of L and L and L and L and L. That's 5 L's. 1, 2, 3, 4, 5. And each L represents that person, that randomly selected person living to be 41. Now, are these independent events? Well, does the probability of one person living to be 41 affect the probability of another person? In this case, no, it does not. So these are independent events. So we would find this probability by multiplying the probability of L 5 times. So I'm just going to say to the 5th power, because it will be the probability of L times 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 the probability of L. So it will be multiplied 5 times, which is the same as saying the probability of L to the 5th power. Well, we know the probability of living to be 41 is this 0.99757. So we want to take that number and raise it to the 5th power. All right, so if you do 0.99757 to the 5th power, you end up getting approximately 0.98791. So the probability that 5 randomly selected 40-year-old males will live to be 41 is 0.98791, which is pretty high. That's like a 99% chance that all 5 of them will live to be 41. All right. Well, what is the probability that at least one of the 5 randomly selected 40-year-old males will not live to be 41 years old? And so in this case, what we want to do, since it's at least one, we want to use the complement, okay? So in this case, we want to do 1 minus the probability that they live to be 41, that all 5 of them. So that will be 1 minus the probability of them living to be 41 to the 5th power. So in this case, it will be 1 minus the 0.98791, which that comes out to be approximately 0.0121. So it's approximately a 1% chance that at least one of them will not live to be 41. So this is a probability that they will live to be 41. So what's the probability that at least one of them will not live to be 41? And so that's approximately 1.21% chance. All right, on the last part of that problem, I end up deleting it, but the answer was 0.0121. And another question that it might ask you is this unusual? And so what we want to, the number we want to use as our standard is 0.05. And this number is less than 0.05. So since this is less than 0.05, we would consider this unusual. Remember we talked about probabilities when they're less than 0.05, then it's considered unusual. When it's 0, it's impossible. When it's 1, it's certain. Well, in this case, it's less than 0.05. So this is an unusual circumstance that one person out of 5, one randomly selected men out of 40-year-old men out of 5 will not live to see 41. So you think about it in real terms, it's pretty rare to see someone die that early. I mean, it does happen, but it's a rare situation. So this is how we will work these problems, at least probabilities and probabilities that are independent. If you have any questions about anything we talked about in this video, don't hesitate to reach out and let me know your questions. If not, I will see you all in the next video.